Hi, so today I want to go over some concepts about imaginary numbers, right? And what are imaginary numbers? So, imaginary numbers, if you can see the example we have written, 1 over I to the third. Imaginary numbers is this little I, right? It's this variable, and this I stands for a very specific number. It stands for the square root of -1. And the reason why this number has its own special a special variable has I is because there really is no answer for the square root of -I. -1, excuse me. Because any number, so let's take 1, right? So if we have 1 times 1, we're going to equal 1. So the square root of 1 would be 1. And if we were to take the negatives of these ones, so -1 times -1, that would also equal 1 because the negatives cancel out. So the square root of 1 can also be -1. So where can we even get an answer that would equal square root of -1? So in that case, we have our own variable for it. And these are going to be, you're going to come across imaginary numbers across Algebra 2, across the SAT, the ACT. They have a common appearance and across all those standardized tests. So I would want to work on solving a couple of them. So the first thing you want to know about imaginary numbers is that because there's a square root here, we can eliminate the square root, right? So if we were to square, right? If we were to square the square root, then it would eliminate this square root. So when we have I to the squared, we can just rewrite this number without the square root. So if I equals the square root of -1, I squared equals -1. So if I equals the square root of 1, I squared equals I squared equals -1. And let's take it a step further, right? Because let me rewrite this. So this is equal to -1, right? Because I squared is I times I, and I equals square root of -1. So I squared is equal to square root of -1 times the square root of -1, and the square roots cancel out. Now let's look at I to the third. Right? So I to the third is simply I squared times I. So what's I squared? I squared is -1. And what is that multiplied by? I, which is the square root of -1. So the square root of -1. So what's square root of 1? Square root of -1 times -1? Well, that's the negative of square root of -1. And now let's do I to the fourth. Now remember, I to the fourth can be rewritten as I squared, because when you're multiplying two exponents where the base is the same, you can just add up the exponents. So if you were to do I squared times I squared, well, we know I squared equals -1 times I squared, which also equals -1. So -1 times -1 equals +1. +1, right? And this, if there's anything about imaginary numbers you would want to remember, it'd be this, right? Because this can help you solve plenty of problems, just like the example we have written, 1 over I to the third. And it can also be helpful to know this to help you get to, if you don't know what I to the third is, being able to do I squared times I will be able to help you find I to the third. So this will always be true. So I will always equal square root of -1. I squared will be -1. I to the third will be the negative of square root of -1. And I to the fourth will be +1. Great. So let's look at our problem here. So we have 1 to the I to the third. So let's rewrite that, right? So that's 1. And let's actually rewrite I to the third, as we said, as I squared times I. Because we know what I squared is. I squared is -1. So let's rewrite that. Actually, let me remove the squiggly line. So we can rewrite that as I over -1 times square root of -1. And that can be rewritten as negative square root of -1. So 1 to the I third would be negative square root of negative 1. So let's look at another example of how imaginary numbers can be seen as a problem. So we figured out, okay, what if you were to raise I to some power? Now we're looking at, let's add some i's. Let's add i's and imaginary numbers and regular integers. So here we see 3 minus 2i in a parentheses plus 2 plus 6i in a parentheses. And I just want to make a note that these numbers right here, these are called complex numbers. Anytime you see an expression that's written like this, in this form, a plus b squared, a plus bi, just like that, or even in this case, 3 minus 2i, we call this a complex number because it has a real number, right? It has a, it has this 2, and then it has an imaginary number, bi. This I makes it a complex number. So 2 plus 6i is a complex number, and 3 minus 2i is a complex number because you have both a real number and an imaginary number. So how do we add these two together? Well, luckily we can treat I as like a variable because it is a variable. So we just combine like terms. So let's see. So the 3 and the 2, since these are real numbers, we can combine that together. So 3 plus 2 is 5. And negative 2 and positive 6, we can combine those together because they're like terms. And that would give us negative 4i. And that's all there is to it. When you're adding complex numbers that have imaginary numbers in them. Okay, let's look at this other example. Now we're multiplying complex numbers. Now we're multiplying 3 minus 2i times 2 plus 6i. And maybe this looks a little bit familiar to you if you're familiar with quadratic equations. Those equations that look something like this, right? So we would actually solve them the same way. You would simplify this expression the same exact way. You would use the FOIL method. The FOIL method. So you would multiply the first terms, the outer terms, the inner terms, and the last terms. So let's do the first terms. So 3 times 2 would be 6. And then outer terms, so 3 times 6i would be 18i. Inner terms, negative 2i times 2 is negative 4i. And then finally, the last terms. So negative 2i times 6i, that would be negative 12i squared. And then we can simplify. We can combine like terms. So let's see. So 18i minus 4i would give us 14i. And let's rewrite the 6. So then we have minus 12i squared. We know what I squared is. We know I squared is negative 1. So negative 1 times negative 12 would be positive 12. And we combine the 12 and the 6 together to get 18 plus 14i. So anytime you are multiplying complex numbers like these, you can use the FOIL method, just as you would use if it was a quadratic equation. Now let's look at a special case. So what if we were dividing? What if we were dividing the complex numbers? So this actually requires a very special case. In this example, we have 2 plus I divided by 3 minus I. And before we can even begin this process, we actually need to do a very specific thing. So we need to multiply both sides by the conjugate of the bottom number. And what is a conjugate? Well, the conjugate is this number, the denominator, with the middle sign reversed or flipped. So if we had, for example, 4 plus 6i, so for example, if we had the number 4 plus 6i, and we had to find the conjugate of this, well, we would rewrite 4 and 6i, and the only thing that would change would be this plus sign. It'd become a negative. And same thing if we had a negative, this sign would flip and become a positive. And that's all the conjugate is. So we're going to take the conjugate. So that's going to be 3. The middle sign is flipped, plus I. And then 3 plus I. And then from here, we're going to FOIL, right? So we're going to FOIL these two complex numbers on top and then these two complex numbers at the bottom. So let's do it out. So 2 times 3 is 6. And then outer would be 2 times 2i. And then inner plus 3i. And then last would be at plus I squared. Right? And then now let's look at the bottom. So 3 times 3 would be 9. And then negative I times 3 would be minus 3i. And then outer would be plus 3i. Last would be a negative I squared. This I looks a little funky. Okay. And now I'm going to simplify all this. So let's see. So 6 plus 5i. And then that I squared is a negative 1. So this is going to be 5. Excuse me. So we know that these two cancel out. Negative 3i plus 3i. That's going to equal 0. That I squared is going to be a negative 1. And there's a minus here, so a negative and a negative would be a positive, so it would be plus 1. And then we have 9. So 9 plus 1 is 10. So this would be our answer. And we could simplify this further. We can divide by 10 on each term. So we could get, if we wanted to simplify, we would get 1/2 plus 1/2 I. And it would be in the form of a complex number, of course. So these are like the 4 main ways that you're going to encounter complex numbers and imaginary numbers. It's very important that you do review these because they are going to show up in your classes and on the test. And sometimes if you're lucky, you might get a question just like this where all you need to do is find out what I is equal to, raised to whatever power. And in any case where you have to multiply, add, or divide them, or even subtract them, hopefully you find this helpful in teaching you how to do this and not be so intimidated by the i's and then the conjugates and then the 3 and the 2's or any other real numbers that you encounter, because they're very similar to how we solve quadratic equations. So thank you so much.